the last video that we're going to be working on, or the last topic rather, is physical and chemical changes. We went over this a lot. Still pretty confusing, no doubt about it, but hopefully the labs today will refresh your mind of how they work. Physical change is going to be a change in the state of matter of an object. No new substance is formed. Okay, whatever happens during this physical change typically can be reversed or undone. Okay, so examples of that would be like freezing, melting, boiling. That's where the whole change in state of matter comes into play, because we know that's how our solids, liquids, and gases change. And then of course cutting, crumbling, and painting. Now painting, I'm just going to fast forward a little bit. When we talk about chemical changes, we talk about a new color being formed. Okay, well painting is a little bit different. Okay, if I take this white wall up here and I get some blue paint and I paint this white wall, it's still the white wall underneath. I've just changed the color over the top of it. Okay, now the chemical change and the color is a little bit different. But right now the most important thing for you to know is that painting. Chemical change, a change in which a new substance is completely formed. Okay, like you can't get those old properties back. It cannot be reversed once it's done. So that's going to be like, signs of this would be burning, rusting, something putting off some smoke, seeing some bubbles, some fizzing. Maybe there's a new smell. When stuff burns, you typically can smell it. Releases heat. Think about a campfire. It warms you up. And of course, new color. But these are just some examples of signs that you would see when a chemical change occurs. And then of course, up here is your examples of your physical changes. And so Ms. McCluskey is actually going to come in and show you some hands-on examples of some physical changes, and then I will close up doing some chemical changes.
Okay, so we're going to start with physical changes, okay? So over here, there's several things that you can do that would be a physical change versus a chemical change, okay? So let's start easy with this piece of paper. So I have this piece of paper. What if I were to tear it like that? Is it still a piece of paper? Yeah, still a piece of paper. So all you've done is tear. You've just physically changed what it looked like. What if I were to crumble up this side of it? Is it technically still paper? Yep.
Can you uncrumble it, Ms. McCluskey?
You absolutely can uncrumble it.
Yeah, it may not look as beautiful as it once was, but it can be reversed, and that's a key thing here.
One more thing that you can do with paper is you can cut it. And even if I cut it, is it still technically paper? Yeah, it's just in a lot of smaller pieces, right? So that was paper. Another thing we can do is Play-Doh. So Play-Doh, when it comes out of the jar, oh goodness, when it comes out of the jar, it's not a lot, but anyway, it looks just like a crumbled up mess. You can make it into a ball, roll it up into a ball. You physically changed what it looked like, but it's still Play-Doh. I could make it flat on the table, still Play-Doh. You can do anything you want to with it, and all you're going to do is physically change what it looks like, okay? So, there's that one. Last one is a candle. Now, Ms. Barnett's going to talk a little bit about certain things about the candle that may be chemical, but right now I'm going to show you the physical change that can happen in a candle, okay? So we see up here on the board that an example of a physical change is melting. So what I'm going to do is I'm going to light this candle, and this, there we go, the wax on the inside is going to melt. The candle wax is going to melt.
Ms. McCluskey, what's happening to the temperature that's causing it to melt?
The temperature is very much increasing. It's really, really hot. An increase in temperature means that it's getting hotter, and a decrease in temperature means it's getting cooler. So right now, it's definitely getting hotter, and it's going to take it a minute or two, but it's definitely going to start melting that candle wax. So let me ask you this though, if you melt the candle wax, why is that not a chemical change? What's the one thing that would make it more physical than chemical? It will be the fact that you can let it cool off, and the temperature decreases back down, and it cools off, it's going to form back up into the wax. So That's what causes this to be a physical change when you melt. Okay? Alright, now she's going to do the chemical changes.
So while we're still thinking about this candle and these matches, we saw on the board that like burning is chemical, smoke, a new smell, releasing heat, putting off a light. Okay, whenever this light right here, obviously it's producing heat right now, putting off some light. I can smell it, and that's all chemical. So, for instance, just this right here, just me lighting this match. Whoops. So just this right here, it's putting off a light. You see the flicker? You can tell that the wood is burning. You can even hear it crackling. And obviously there's some heat. Once it gets close to my fingers, it's going to burn. And you can smell it. And so that's an example of a chemical change as far as like lighting a match or lighting a lighter. Okay? I cannot get the match back. Okay? It's burnt. It's changed forms. Ash is there. You know, a lot of times once smoke and ash has occurred, it's over with. You can't get it back. Okay, but remember the wax melting, keyword melting, is physical. So another thing I'm going to do is, this is the grand finale here, I'm going to put it to the side. But if you can remember, back towards the beginning of the year, we blew up balloons using Alka-Seltzer and water. Okay? And so this is actually a chemical change, and the reason why this is a chemical change is because when you mix the two together, it starts fizzing. So you see the fizzing, you see the bubbling, and then obviously it's creating something. It's creating a gas. It's putting off that gas, which is what causes the balloon to blow up. So Miss McCluskey's getting them ready to put in. As soon as she gets them in, I'm going to put the balloon on. Let's watch what happens. Something doesn't seem right here, so we're going to add another one. Could be my amount of water. Alright, so what you can't see right now is that the bubbles are fizzing up and bubbling, and you can actually even hear it making a sound.
There we go.
Now, if you notice, the balloon is finally starting to blow up. That's the thing about science labs, guys. It's really trial and error. You never know what's going to happen.
I think if we had a little more water, that would have been just right.
Yes, a little more water would have given it some more power. In class, they've gotten much bigger than this. But it gives you an idea, okay? The gas was released because of the chemical reaction between the Alka-Seltzer and the water, which in return went up into the balloon, which is causing the balloon to expand. Okay, and remember, gas is the state of matter that takes the shape of its container. Okay? If the balloon was not here, the gas would just be released out into the air. I'm just going to put that to the side. So, the final thing that I'm going to do, okay, is for chemical changes. We've done lighting a match. We've done the Alka-Seltzer and water chemical reaction that causes the gas to be formed that blew up our balloon. The very last one is fun to me because anytime you get to play with baking soda and vinegar is fun, smelly but fun. And so in here, I've kind of put some food coloring in the vinegar just to kind of see maybe if it has a little color to it, make it a little more interesting. And so I'm going to take this baking soda and drop it in the vinegar. We're going to see what's happening. Okay? And so the gas that's formed during this is carbon dioxide. Okay? So I'm going to put some in there. And you notice it automatically starts fizzing up. It's foaming. It's a chemical reaction. Okay? That's what causes it to shoot up. If you remember, whenever we did the rockets, we had the bottles with the caps, And what happened was we put the vinegar in, we put the baking soda in, we put the cap on, set it up, and it actually shot off. Now, because we're indoors, we can't do that right now, but as you can see, it's basically a volcano, okay? This is a chemical reaction, okay? I can't get this stuff back once it's done, okay? It's already together. There's foam, there's bubbles, an explosion occurred, okay? So this is just kind of the rundown on physical and chemical changes, stuff you've already done, stuff we've done in class. Actually, right now, I'm noticing you can't really see from there, but there's already some wax beginning to melt. Okay, after the video, we'll blow this candle out, and by the time we leave today, the wax will have hardened back up. So, therefore, that would have just been a physical change, okay? But can't get my match back. That was a chemical change. So, I mean, if you have this stuff at home, you can do it at home. You know, do it with your siblings, do it with your parents. It's fun stuff. You know, if I had it my way, we probably would have blew a rocket up in here, but it don't work that way. So anyways, thanks.